Hello, welcome. Today let's try to solve another Leetcode problem 207 course schedule. So we are giving number of courses. So this 2 means we have 2 courses, and this prerequisites array means there is a course. So for this 1 and 0, actually it means 0 is the prerequisites of 1. It means if you want to finish the course 1, you have to finish the course 0. So this is basically a graph problem, and the first node of the graph is 0, and the last node is n minus 1. So for this one, it is 2 minus 1. So the last node is 1, the first node is 0. And let's check the next example. So for the prerequisite, it means if you need to finish the course 1, you have to finish the course 0. And for this one, it means if you want to finish the course 0, you have to finish 1 first. So this means this is a loop. You can never make it work. So this is the graph problem, and we need to solve it in topological sort. Of course, you can use the DFS and BFS to solve it, but the time complexity is much higher than topological sort, because for topological sort, the time complexity is just O m plus n. So n is the number of courses, so the number of nodes. M is the number of prerequisite. So that is why we need to use the topological sort to solve the problem. Let's check all the pairs the prerequisites I are unique. So it means the edges always be unique. So this means we can use the topological sort to solve the problem easily. And let's check others. So the length is 5,000 and the number of courses is 2,000. It means 2,000 plus 5,000, basically it's 7,000. So this is why topological sort is so fast. Let me write the template for the topological sort plus BFS, and later while I'm writing the code, I will explain why I write the code like this. So basically for the template, we need to prepare a graph. So the graph will be default dict list. Because you need to prepare an adjacency list to store the node and the edges. So for example, this one. So the node is 0 and this 0's edges is 1. So it means there is a 1 connected to this 0. It also means 0 is the prerequisite of 1 in topological graph. We need also to prepare an in-degree array. So this in-degree means if inside the in-degree, if the number is 0, it means basically this course can be finished first because there's no prerequisite. So for example, so for this 1 and 0, so for the course 0, actually, for the course 0, so the in-degree 0 is 0. It means there's no prerequisite for the course 0. So the in-degree will be a list. So the list inside it will be 0 times the number of courses. Let me copy this variable. Now we can prepare for the graph. So for UV, this means the 2 edges inside the all edges. So for UV in the prerequisites, so V is the first course we need to finish. It means we have to finish 0. After that, we can finish the course 1. So for the graph, we need to prepare for the V, gv.append this U. So it means so for the 0, it is the node, the vertices of the graph, and the ends. So for this one is connected to 0. So it also means for the 0, the degree should be the degree for the 0 node Yeah, so for the node 0, it should be 0. Yeah, and the integrate. Yeah, so for the integrate yield should +1. Yeah, let me explain a little bit about this one. So the integrate yield, so this means it is 1. So for 1, it means the integrate should +1. So for example, yeah, like this. So we have a node 0. After 0, we have a node 1. So this 0 is connected to the node 1. So this means 0 is connected to 1. So this means there is an integrate of the node 1. Yeah, but for the 0, there's nothing. It is still 0. Now let me print out the graph and integrate array. You can understand easily what I mean. Yeah, let me return a result as 0 first to check what is the degree and what is the graph. Yeah, now we can. Yeah, now we should ignore the result because I didn't write the function for the result. We can check this. So for the adjacency list, as you can see, this 0 means for the node 0, this cost how many. If I want to finish the cost 1, so for example, this is node 1. If I want to finish the node 1, the cost 1, I have to finish the 0 first. So for the graph, 0 is connected to 1. Yeah. So this is why we prepare the adjacency list for the graph this way .append u. So this means this 0 is connected to 1. So the integrate for the node 1 has a 1, but for 0, it is still 0. Yeah. So this is the preparations for the topological sort by using BFS. Yeah, if you understand this, so for the others, it should be much easier. Yeah, because we always use the zeros inside the integrate array to count how many nodes, how many courses we can finish first. If the courses equal to the number of courses, if this result equals to the number of courses, it means we can always finish this course. Yeah. Now let me just delete this lines and continue for the BFS. So for the BFS, it should be much easier. Now we can prepare a result as our counter. And now we just need to check the Q. So for our Q, we need to put the zeros inside the integrate array to our Q. Yeah, we need to put those nodes inside the Q. So I would define a Q as the Q. So inside it will be I for I n in enumerate degrees, in degrees. So this means I want to put the node inside the Q if the value of if the number of this node is 0, if this n equal to 0. Yeah, so this means if this number is 0, I would like to put it inside my Q first because I can use BFS to search from this 0 to others to expand. Yeah, to check how many of the courses I can finish first. From the beginning, the result is 0. Then I will need to check how many of the courses I will update the result if there's a 0 inside my queue. Yeah. Now I can use the queue. So while queue, the node should equal to q dot pop left. Yeah. After I pop it out. So for example, for this example, after I pop out the node inside, it is 0. Yeah. So after I pop out this 0, I need to check how many nodes connected to this 0. Of course, this 1 is connected to this 0, as we can see from the graph. Yeah, this 1 is connected to 0. So we need to check. So for n is just a node. Let me make it a neighbor. Yeah, so for neighbor in graph of this node. So inside the node is 0. The n, this neighbor is 1. So this 1 is checked. So this is 1. This neighbor is 1. So for neighbor inside the graph, we need to update these neighbors, because before the in degree is 1. If it is inside the graph, we need to update the in degrees. So in degree with neighbor should minus 1. Why? Yeah, because for this 0, it means I can finish this 0 first, and then I connect it to 1. If I can finish this 0 first, it means this means my in degree for this node 1 should be minus by 1. If after minus by 1, if it is 0, it means I can also finish the course 1. Yeah, it always depended how many courses connected to this node. Yeah, so up to now 0 is connected to it. Yeah, if I finish 0, it means 0 will not connected to this 1 anymore. So for the in degrees of this neighbor, so for the in degrees of the node 1 should be minus by 1. Yeah, so if the in degree of this neighbor equal to 0, so this means this course can also be finished. Yeah. So what should I do? I should put it inside the queue, because while I pop out the node, my result should always be plus by 1. I count my result according to how many nodes inside the queue. Yeah. So from here, I need to put it inside the queue. So queue.append this neighbor. So this node. If it is 0, I always put it inside. Anyway, I will code how many results. So I just need to return if this result equal to the number of courses. Yeah, so this is actually the entire code. It is not that so complicated. Yeah, basically this is also the template for topological sort of BFS. If you can solve this problem, yeah, course schedule 1, normally you can solve course schedule 2. Later on, I will try to solve course schedule 2, but let's run it first to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass for all the testing cases. Yeah, as you can see, it's pretty fast. It's nearly 94% of all submissions, and the time complexity is just O(m) times n. Let me analyze the time complexity again. So basically here, you didn't consume any time. Yeah, because this is just a 0 time number of courses. Maybe here 0 times the number of courses. Let's say the number of courses. Yeah, this is just O(n). And also for here, yeah, this also takes the O(n) space and O(n) time. And here, so for the edges, so how many edges we need to prepare the graph. Here takes the m. M is the length of the prerequisites. Yeah, so basically it is 2000 plus 5000 for the time complexity. Because for this queue, actually, the time complexity is just O(n). It depended on how many courses, how many nodes. Because basically, we just code how many nodes inside this queue. Yeah, and for the space complexity, it is also O(m) times n. So for here, for this queue, it is still O(n). But for the graph, it is O(m). And for the time, here is also O(m). So this is why the time complexity equals to the space complexity equals O(m) plus n. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.